Guys, what you're saying is a numerical of the cantilever beam. In the case of a cantilever beam, there is only supports at one side, and that supports is not a hinge support, that is a fixed support size, something like this. So what does it mean? Guys, can I hold the pen like this? I can't. Suppose if it is a hinge, it falls. I have to hold it like this. That means when I hold it like this, then it is this way. That means I am trying to create a moment. I am trying to create a moment like this. Okay, as well as I am supporting this vertical load. So at the fixed end, there will be two, one reaction force and one reaction moment. So this is how the cantilevers are different from simply supported beams. So similar to the previous problem, you name this as A, you name this as B, name this as C and D. Okay. Now we will first convert this into, of course, you can start solving the problem like this only, no problem. Draw lines like this here and draw a line for SFD and BMD. Okay, you can do that later. And then here, very similar to the previous problem, you should say that moment about A is equal to 0. So that means at this point, the moment, the sum of the moments are 0. So here, what you say is that at this point, moment about A. So there are moments here. One is this moment about A itself. So these are the external moments acting. External moments don't need any forces. This is already moment. This is already force into distance. Okay. So we have already seen clockwise moments can be taken as positive, anti-clockwise moments can be taken as negative. So there is one anti-clockwise moment here. So if I take a moment about A is equal to 0, first the moment starts is minus MA. Minus MA is the moment about this. So moment about A itself is minus because it is acting that way, and then you have this 20 kilonewton acting at what distance? 2 meter distance, and then this is visible. So I should have moved this. Okay, and then now which are the other forces? What are the other forces? 10 kilonewton into how many meters? 4 meter into 3 meters. Acting at what distance? Acting at what distance? This whole UDL can be clubbed as a point load. So at what distance is the point load? 2 plus 3. So 3 plus 1.5, 4.5. So 4.5 meters. So here minus MA, so that is plus 40 kilonewton meter and plus history the answer now. $30 into 4.5, 135, huh? 135. So you can say MA is equal to 135 plus 40, 175. So you found out MA is equal to 175 kilonewton meter, and then sigma sum of the force is equal to 0. So upward forces are equal to downward forces. Upward forces, there is one force acting here. So reaction at A. So there is moment about A. Moment about A is found out. Moment about A is equal to 175 kilonewton meter. That is found out. And we need to find out RA here. So forces which are going upwards is only RA. There are no forces going upwards other than that. So RA is equal to plus 20. So which is on the other side. So the forces going upwards is equal to forces going downwards. 20 plus 10 into 3. So 10 into 3. You don't have to multiply distance and all because it's just forces. Okay. What's the answer? 50. So this is 50 kilonewton. So RA is equal to 50 kilonewton. So once you have done this, around 80% of the problem is done. Sorry, about 40% of the problem is done. Because if you go wrong here, then the rest of the problem will go. But usually, when you have got this step, the rest of the problems will automatically fall in place. So RA is equal to 50 kilonewton. Guys, once you have done this, then draw a SFD line. Guys, now what do you feel? Guys, this, when you got this beam like this, when you got the loads like this, will the beam go like this? A, or will the beam go like this? B? B. Okay, when the beam is going like this, whether it is hogging or sagging? Hogging. When the beam was going like this, it is sagging. So when this beam is going like this, it is hogging means negative. So that means if you draw a line here, the bending moment will be below. So you need to make space for bending moment. Anyway, now we are drawing SFD, no issues. So SFD, now what about SFD? SFD, if you suppose any force going downwards is, it is actually positive. So here if you actually see, all the forces are going downwards. If all the forces are going downwards, so you'll have a lot of forces going above the zero line. There is only one force going below the zero line at this point. Okay. So therefore, we'll have to have some space above here. So before you solve the problem, you now should be able to estimate how does the curve come, and also know the place requirements. But that is estimation analysis. So here I am. So the same procedure now, whether it is moment or this, it doesn't matter. Now the shear force, now the shear force at this point is 0. And now as you go further here, you will have UDL added. So continuously UDL is getting added for every 1 meter. Suppose if you move by 1 meter, you add actually 10 kilonewtons. If you move by 3 meters, you add how much? 30 kilonewtons. So it goes from 0 to 30. So now we are here, the total UDL is 30. So now it goes from 0 to 30. Straight line here, 0 to 30 kilonewton meter. Now again you go further here, it doesn't increase because it is the same 30 kilonewton, because shear force is just force, distance is not worried. So okay, as you go from here to here, more UDL got added, so it was increasing. Now after this point, UDL is, these forces are not increasing because there are no forces in between. So it remains constant. Again when you come here, will it increase? Again when you cross this, will it increase?
Yes.
How much?
20.
This is 20 here. Now it will increase to 50 here. 50 kilonewton. It will increase to 50 kilonewton here. Okay, once it increases to 50 kilonewton, it will remain as 50 kilonewton here. It will remain as 50 kilonewton up to this point. And then RA equal to 50 kilonewton. So RA reaction force was like this. When you see this reaction force, then one force going upwards on the right hand side, it is negative. So from plus 50 it goes to 0. So once you have drawn this, you understood that there is a huge amount of shear force at the fixed end. Okay, and then to draw bending moment diagram. Now to draw bending moment diagram. Bending moment diagram, we said throughout it will actually bend like this or like this. Like this, will it bend like B or A? B. So that means it is hogging. Hogging means it will be negative. So if you actually have space above, that's useless. So therefore I will draw this zero line above itself, because now the whole diagram will come below. So 0 kilonewton meter. Okay. Now I start very similar to the simply supported beam. I am here. What is the bending moment diagram? Sorry, what is the bending moment? Sorry. So bending moment at D is equal to 0. What about bending moment at C? Bending moment at C is, so now as per the convention here, anything going upwards is positive, but it is going downwards. What is the value here? Minus 10 into 3. So minus, okay, write with units. Kilonewton per meter for 3 meters. Distance is 3 meters. So meter gets cancels out. What you have got is 30 kilonewton into 3, 90, and then that's it, no? So there is only one. So it is minus 90.
That should be 1.5.
Sorry. 1.5 meter. The whole UDL acting at half the distance is 45. Minus 45 kilonewton meter. Okay. And then you now go here. Then you go here. Guys, if you go here, you can still find, otherwise you have to take like this. I can do it in both the ways to make you comfortable. Now don't worry. Comfortable andre ivaga hege andre ivaga sometimes you are not understood how to handle these moments. You can understand how to handle the moments. Now I will try to see right side and solve. So when you are here, so how does this change? So okay, right above. Bending moment at B. Bending moment at B here. So what is the answer, guys? This 10 kilonewton, is it plus or minus? Minus going downwards into 3 meters, acting at what distance? Acting at what distance? 1 plus 1.5. So that is 2.5. So 2.5, and then is there any other things? No, there's only one. Okay, so what is the answer now? How much is the answer? So 30 into 2.5, 60, 75. So minus 75 kilonewton meter. So it was 0 here. Bending moment at C became minus 45. So here you can see that here it is already inclined. So here it will be parabolic. People can draw like this. Or people can draw like this. I think examiners will not penalize however you draw it. But only one thing. Here if it is an inclined line, here it should be a curve. Okay. Here it is x to the power of 1. Here it is x to the power of 2. So that means it is varying with the distance. Okay. So therefore, it's a parabolic curve like this. It goes like this. More and more distance, more and more bending moment here. It increases. And then, so it reaches a value of minus 45 kilonewton meter. And then At this point it becomes how much? 75. So now you see that from here to here it was an inclined line, so it is a parabola. Here it is x to the power of 0, here it is x to the power of 1. X to the power of 1 is a straight line. So from here to here, it should be a straight line. From where to where? 75. So 45 is so much, 75 is this much. So here it should be clearly written as a straight line. Okay, here it should be clearly shown as a curve. Okay, now once you have done that, finally at this point, if you want to calculate, you should calculate wherever there are moments like this, wherever in the beam, at the A there was moment like this here, MA here, what I will do is, I will try to calculate just on the right side of this moment, here. So finally it will become 0 at this point. Before this point, I will try to calculate. So I think in the case of cantilevers, people feel it difficult while calculating moments at this point. So you know that moment which was there here is already 50 here. So you don't have to worry, because earlier you had calculated to calculate this. So anyway, if I try to do it again, you will get it the same answer. So here, moment at A onto the right side of A, moment at A onto the right side of A. Okay, so that is about this without considering the moments here. So just on the right side of A. So that is, we had calculated earlier 20 into 2 this and all, which became how much? Is to 50 alva. So last time we calculated. So we calculated this earlier. So we got this answer. It is 50 kilonewton meter. If you want me to calculate again, I will do it. It is just onto A. It is plus 20. Sorry. It is minus 20. Minus 20 kilonewton multiplied by, what is the distance? So 2 meters. And then this UDL plus 10 kilonewton for every meter or 3 meters, acting at a distance here. So this is 2 plus 3. So 3 plus 1.5, 4.5 meters. This is just nothing but, sorry, both are negative. Both are negative. This was minus 50 kilonewton meter. Earlier I calculated this.
So minus 175.
So minus?
175.
Sorry. You minus 175.
Yeah.
Yeah, sorry. It is not 50, it is 175. We have calculated, sorry. So we have calculated this, it is 175. It is 175 kilonewton meter. So area was 50, sorry. Area was 50. We already calculated MA as 175. So it is minus 175. So then it goes to 175 here. I think people just use this value and just put it. Okay. And here you see that here there is, okay, here it is x to the power of 1. Here it is x to the power of 0. Here it is x to the power of 0, which is a flat line. So here it has to be straight line. So it goes from 75 to 175 like this. (175 kilonewton meter). Maybe it is not visible in the It's not visible. Is it visible if I draw it here?
Yes, sir.
Okay. Okay, it is 175 kilonewton meter. So once you have done this, you shade this area here, and again 175. Okay, 175 you are done, and then it is 175. And again when you come across this point, this anything on the right hand side. Now this moment is positive. Minus 175 plus 175, it becomes 0. So moment about A onto the left side of A, that is minus 175 kilonewton plus 175 kilonewton meter, it becomes 0 kilonewton meter. Okay, but people just take this value and do it. I think it makes no difference. So once you have done this, then you need to shade this area. You can shade this area to left side or right side, wherever the way you want. Okay, now we can understand why that aeroplane wing had to be made so thick at this point. Because there are a lot of loads here. We will have huge amount of shear loads, huge amount of bending moment. So there, suppose if the wing fails, it will fail at the point where it is connected to the fuselage. Okay, so we have huge amount of bending moment. And it is also the same case with the branches of the trees. Branches of the tree doesn't fail somewhere. It usually fails where it is fixed onto the whole stem. Okay, so it is very critical. So it finally becomes 0 kilonewton meter. This is how you need to solve a cantilever beam.